Okay, good day. Welcome back. In this video, I will show you how to solve a DC short shunt generator where a short shunt compound generator supplies 100 amperes at 110 volts, armature resistance of 0.05 ohm, shunt field resistance of 57 ohm, RS or the series field resistance of 0.04 ohm, iron and friction losses amount to 852 watts. Determine the overall efficiency of the generator. Iron and frictional loss. These losses are the stray losses. But first, we have to write the given. IA of 100 amps. No. IL of 100 amps. VL of 110 voltage. RA of 0.05 ohms. RSH of 57 ohms. RSE or the series of 0.04. Frictional loss or the P stray is equal to 852 watts. Now the question is the overall efficiency or the N. What is required is the overall frequency efficiency. Okay, let's start with drawing the circuit. Now we have here the power flow diagram and the short shunt generator circuit. So it is very important to know the power flow diagram. What is missing is the overall efficiency, which is overall efficiency is equal to P out over P in. So we have the overall efficiency. Therefore, P out over P input. Okay, let's start with finding the. Now P out is given. We can find P out by here VLIL. Now VL is given and IL is already given. Step 1. P out is equal to VLIL. Therefore 110 times 110 volts times 100 amps, which is 11,000 watts. Now we have the output. What is missing is the input. Here it is already given the stray losses or the core and friction losses is given. Now what is missing is, if we have the P output, we can just simply add the copper loss and the stray loss to get the power input. But there is also a another approach to this question, which is P output or the P developed in the armature plus the stray losses, we can get the P in. Let's try this first approach. We use P dev or the P power developed in the armature plus the power stray losses to get the P in. So to get the power developed in the armature, we use EG-IG. While EG is still missing, let's find EG. To find EG, we must get the ISH and IA. VSH is equal to 110 here from this loop outside. VSH equals 110 plus 100 times 0.04. So this is the VSH or the V here. Now we have 114 volts. Now ISH is equal to 114 volts over RSH of 57 ohms equals 2 ampere. Now another IA is equal to IL plus ISH. It is 100 amps plus the ISH of 2 amps. Therefore, IA is 102. IA of 102 amperes. Now that we have the IA, we can get EG. So what is the formula of EG? EG is equal to VL or the V plus IA RA plus IS RS. Then we have EG is equal to 110 plus ISRS of 100 times RS of 0.04 plus 102 times RA of 0.05 plus 100 of RS of 0.04. It must be 119.1 volts. Now that we have the EG, we can get the PA or the power developed in the armature, which is equal to EG here times IA here. Okay, it is equal to 119.1 times 102 amperes equals 12,148.2 watts. Okay, so we have now the PA, which is the 12,000, and we have the losses. Now we can get the P in, which is P input is equal to P stray plus the power developed in the armature, which is stray given 852 watts plus 12,148.2. Power input is equal to 13,000.2 watts. Now that we have the power input for the final, the efficiency is equal to P out over P in. Now we already have the P out and the P in. Therefore, the overall efficiency is equal to 11,000 watts over 13,000.2 times 100. 84.6%. Well, we can use the shunt. We can use the power output plus the copper losses plus the stray losses to get the P in. But in this example, in this solution, we get PA plus P stray to get the power input. Therefore, the overall frequency is 84.6%. That's all. Thank you and see you for the next video.